Good morning, students. Today we are sharing our class with grade 8 and 10. Okay, and according to NEB, okay, in both grade 8 and 10, you need to learn the topic pressure and the basics of pressure, or the first part of pressure is basically same as the lesson you studied in grade 8. So this part of lesson pressure is the same for both grade 8 and 10. That's why we are combining the class. Okay. In this lesson for both grade 8, which is useful to both grade 8 and 10, we will be studying the pressure, definition of pressure. Okay, its mathematical relationship, and then after its SI unit and numerical related to it. Okay, and some reasonings. Okay, this much we will study in this topic. Okay, let's go through the definition first. How do you define pressure? What is pressure? Okay, you all know force. Yes, force means an external agent which is applied to any object. Okay, now let's talk about a surface. This is a surface. If you apply force, you can apply force on these surfaces in any direction. From any direction you can apply force, isn't it? Okay, that is force. Yes, however, if you apply force in perpendicular direction only, then that is called thrust. Okay, the total amount of force applied on a surface perpendicularly is known as thrust. Remember, you can apply force in any direction. Yes, you can apply force at any angle. At any angle you can apply. But if you are applying force in 90 degree, then that is called thrust or total force. Yes, now the thrust is being applied on total area, but if you calculate the thrust being applied on only unit surface area, that means 1 meter square, you take 1 meter square of surface area, yes, 1 meter length and 1 meter breadth, then how much thrust is being applied on that much surface is known as pressure. Okay, this is the basic concept. I need to lower the camera. Okay, they get it or not? Force is an external agent applied on a surface that changes or tend to change the state of motion, instead of an object from rest to motion or motion to rest. Now force can be applied in any angle, isn't it? It can be applied in any angle, but if the force is applied only at 90 degree angle, then it is called thrust. And how much amount of thrust is being applied on unit surface area or 1 meter square area, that is called pressure. See, so pressure is very easy to define. Pressure is defined as thrust applied, okay, let's applied per unit surface area. Okay, now instead of thrust you can also write force. Okay, force applied perpendicularly. Okay, you can, instead of thrust you can also write this. Yes, if you do not remember the word thrust, you can write that. Pressure is defined as force applied perpendicularly, applied per unit surface area. Okay, either you write for pressure is defined as thrust applied per unit surface area, or you write pressure is defined as force applied perpendicularly per unit surface area. So by definition, what do you get? Pressure is equals to, it is total force, isn't it, applied per unit area. So if you divide total force by total area, then you get how much force is being applied on unit area. Okay, like if 200 Newton force is being applied on 2 meter square area. Okay, if 200 Newton force is being applied on 2 meter square area, then what amount of force is being applied on 1 meter square area? Definitely it is 100 Newton. Okay, so that should be your pressure, 100 Newton per 1 meter square area. Okay, we'll go through numerical later on. Or P equals to F by A. This we are going to use it in numerical. Let's go to SI unit. Okay, what is SI unit of force? As we know, P equals to F by A, taking unit of all terms. Unit of pressure is equals to, unit of force is Newton and unit of area is meter square. So it is Newton per meter, Newton slash meter square. And this unit, Newton slash meter square, this unit has given a peculiar name, that is Pascal, in honor of the scientist Blaise Pascal. Yes, okay, Newton slash meter square has been given a name, Pascal. So we say SI unit of pressure is Pascal, and which consists of Newton slash meter square. See, how to define 1 Pascal pressure then? Define 1 Pascal pressure. How to define it? Okay, from this same derivation you can see, if 1 Newton force, if force is 1 Newton and area is 1 meter square, then it should be 1 Pascal pressure, isn't it? See, P equals F by A. If value of force is also 1 and value of area is also 1, then value of pressure should be 1. That means to say, just remember this, 1 Pascal must be equals to 1 Newton by 1 meter square. Okay, so it gives you the definition. When 1 Newton force is being applied perpendicularly on 1 meter square surface, it is called 1 Pascal pressure. Okay, up here let's revise it once again. Pressure, it is defined, pressure is start taking note, pressure is defined as thrust applied per unit surface area. Pressure is defined as thrust applied per unit surface area, or pressure is defined as force applied perpendicularly per unit surface area. And from that definition we get pressure equals to force upon area. Okay, now to find out SI unit, as you know, P equals F by A, and taking unit of all terms, unit of pressure equals to, unit of force is Newton and unit of area is meter square. So it gives us Newton slash meter square. And this group of units, this derived unit, Newton slash meter square, this unit is also referred as Pascal or PA, in honor of scientist Blaise Pascal. Now, how is 1 Pascal pressure defined? Define 1 Pascal pressure. That means we know 1 Pascal equals 1 Newton by 1 meter square. Okay, because P equals F by A. If value of force is also 1 and value of area is also 1, then we get value of pressure would be 1. That's why when 1 Newton force is being applied perpendicularly on 1 meter square surface, it is called 1 Pascal pressure. Okay, up here I hope there is no confusion. Now I'll go to numerical. Okay, these numericals are very easy and it's very basic. Okay, this lesson is actually not so hard. You have studied about it in grade 7 as well. Okay, you have got it from grade 7, so it should not be very difficult. Let me take a question. Okay, before we go to numerical, I forgot to answer one thing. There's a frequently asked question: On what factors does pressure depend on? On what factors does pressure depend on? And many students ask me that question, but it is actually very easy. You can get that answer from the definition itself. Yes, pressure depends on two factors there: force applied on surface and the area of surface. Okay, pressure depends on two factors: force applied and area. If force is for more amount of force is applied, then pressure will be more. Okay, or if less amount of force is applied, then pressure will be less. Okay, and if area is more, then with this by keeping the force as constant, if area is more, then less pressure will be exerted, and if area is less, then more pressure will be exerted. We will use this fact while doing a reasoning question. Let us first go through numerical. The question states that a brick of 500 Newton occupies an area of 0.5 meters square. Calculate the pressure exerted by it. Okay, I guess 0.5 is also too large for a brick. Let me make it 0.05. Okay, it says that you have a brick, yes, and its surface area is 0.05 meters square, and its weight is 500 Newton. Means weight always acts in downward direction, isn't it? It is 500 Newton, and that means when you place a brick on the ground, you can be sure, you can tell it without any doubt that the force or weight is being applied perpendicularly to the ground. So weight of the brick can be considered as thrust. Okay, now take the given informations. Given weight of brick. Now weight of brick is also the force. Yes, force equals to 500 Newton. Many students does not use does not link the concept here. We know that weight is amount of force, isn't it? We have defined weight is amount of gravitational force or force of gravity exerted on an object. But whenever a question gives you the value of weight and you need to use it as force, you always get confused. Okay, so don't let it be so. Weight of brick is given, and then area of brick is given. Area of brick A is equals to 0.05 meters square. Then pressure exerted by brick P is equals to what? As we know, we all know the formula of pressure. P equals to F by A, isn't it? Or P equals to F is 500 Newton, A is 0.05 meters square. Therefore, it gives us 1000 Newton slash meter square. Okay, 10,000 Newton slash meter square. This is your answer. Okay, any confusion up here? I hope there should not be any confusion. And I'll do one more numerical, and then we'll go to give region questions. Okay, now once again take out this question. Okay, and look at this solution, but do not copy this solution. Okay, do not copy this solution. Pause the video, put your mobile away, put your screen away, and then do it on your own. Yes, that would be best strategy. Okay, next question I'm taking. Calculate the pressure exerted by a brick having mass 2 kg and length 2 meter, breadth 13 meter. Okay, I guess it is too much. Let's say not a brick, Okay, it's okay, break. But this question is given in book, but it seems too much unusual, isn't it? What break would have 2 meter length? And what break would have 13-meter length, and yet it has mass only of 2 kg? That is very much unlikely. Okay, so I'm going to change it at length 0.2 meter and breadth 0.1 meter. Okay, now what are the given information? Let's say given information, given mass m equals to 2 kg, length L equals to 0.2 meter, breadth B equals to 0.1 meter. Okay, now what we need to find? We need to find pressure. P equals to what? Okay, now we know formula of pressure is, what is formula of pressure? F by A. But see, F is not given, is it? No, you are given mass but not force. You are not given force. And A, area, is also not given, but you are given L and B. Okay, so first, before you find out value of pressure, you need to find out, you need to calculate both of them. Yes, that's why here, as we know, first of all, let's calculate force. Force F. Force also correspond to weight. Okay, and the formula of force is m into g. Mass 2 kg and g acceleration due to gravity 9.8 meters/second square, and it gives us 8 to the 16, carry over 1, 9 to the 18, 119, 19.6, and kg meter/second square means Newton. Okay, we have force. Again, we need to calculate area. A is equal to, you know, it is L into B, because a brick is rectangular. Yes, L 0.2 meter into B 0.1 meter, and gives us 0.0212. Okay, 0.02 meters square. And now you have force and you have area. Then you can calculate pressure. Then P equals to F by A. Yes, F 19.6, A 0.02. Therefore, it gives us P equals to, let me calculate it, decimal cancelled, it should be somewhat like 1960 divided by 2. Because 0.02, after decimal there are 2 digits, here also 2 digits, so by adding 0 we can cancel the digit, so it will be 2 1s are 2, 2 9s are 18, carry over 1 16, 2 8s are 16, and 0, 980. Okay, 980 Pascal, and this is your answer. So do you understand it or not? I don't think it is so difficult. Okay, so once again, what you do, pause the screen, take out the question, okay, put your mobile away, and then do the solution on your own. What I have done here, take it as reference. Okay, do not copy it, take it as reference. Okay, do on your own. If you get confused, only then look at this solution and again try on your own. Okay, now let's go to another topic, give reason. We will discuss few give reason questions. Okay, you have studied some give reason questions, not just some, many give reason questions from this lesson in grade 7 as well. I remember teaching you at least 8 or 10 give reason questions in your grade 7 class. Okay, now before you attend give reason questions, you need to know few things. Yes, if P equals to F by A, you know this, and if F is kept constant, F is kept constant means if you do not change amount of force but only you change area of object, then how does pressure differ? Yes, if you keep force as constant, if you do not change force, you only change the value of area, then how does pressure differ? It is to say, like, suppose I have this scale, isn't it? If I beat with the scale, if I beat on an object like this way or like this way, which one produces more sound? This produces more sound or this produces more sound? Or if I am to keep a piece of soap here, will it cut out the soap or will it cut out the soap? By using same amount of force. By using same amount of force. It is pretty obvious that if you try to cut out soap from this surface, it will not be. But if you cut out from the edge, then it will easily cut it. Yes? Okay, and the sound also, by using same amount of force, if I beat from this side, it produces less sound. But if I beat from this side, it produces more sound. Okay, what is happening here? This surface has large area, but this is as very small area. Okay, so if area is small, then pressure would be more. Take another example. You have a nail, isn't it? You have a nail. Yes. If you try to pierce the wood through this end, then it will easily go down. But what happens if you try to pierce the wood like this? What happens? Will it even go down? No, it won't be able to. Why? Because it has more surface area, so it does not apply enough pressure to break the wood. Okay. However, this end, it has less surface area. Okay, so it exerts enough pressure to break the wood and it goes down. That's why if F is kept constant, then P is proportional to 1 upon A. That means area increases, pressure decreases. Yeah, area decreases, pressure increases. Okay, keep this much thing in your mind. Okay, let's deal it. Why is the foundation of a building made wider? Why is the foundation of a building made wider? Okay, foundation means jog. Yes, if this is a pillar of building, suppose this is the level of ground. Okay, this is a pillar of building. Okay, then the pillar of building under the ground is not left as such. It's not left like this. Okay, however, under the building it is made somewhat like this. It is made broader. Okay, pillar under the building, the pillar is constructed like this. So this is called foundation or jog. Okay, so why is foundation made broad? Answer is obvious. By making it broad, it increases surface area, and by increasing surface area, it decreases pressure. So the building does not collapse under the ground over time. Okay. However, if you don't put the foundation, what might happen? Suppose this is your this is a pillar of your building. Okay, this is the level of ground. Okay, and you have not kept broad foundation, isn't it? And this here, suppose this is your room on the ground floor, but after 10 or 15 years, maybe your room will be underground. It is possible, entirely possible. Yes, why? Because it has very less surface area, it exerts pressure on ground, and that causes it sinking in the ground or collapsing in the ground. Okay, that is why we need to make foundation wider. Okay, to decrease pressure. Okay, as we know, P is proportional to, so P equals to F by A, and keeping F constant, you get P is proportional to 1 upon A. So by making foundation wider, it increases surface area. and decreases pressure on the ground. So the building would not collapse. Okay, see, why is the foundation of a building made wider? Because as you know, F is equals to F by A. Keeping F constant, you get P is proportional to 1 upon A. And by making foundation wider, it increases surface area and decreases pressure on the ground. So the building would not collapse. Okay, now you need to attempt some more questions on this regard, give reason. Okay, let me copy some questions, then I'll show you the screen. Let me freeze the screen for now. Okay, these are few questions I have collected. You need to do them on your own. But while giving give reason questions, while attending give reason questions, don't forget to show this relation. Okay, because it will simplify. It will simplify that reasoning process. Okay, it also gives you gives a conceptual framework. Okay, freeze your screen and copy the question, or you can copy as I read them. Sharp knife cuts vegetable easily, but not a blunt one. Why? Question number 2. Track of railway has wooden slip. Why? Okay, this means suppose this is a railway track, then in railway track you know that such wooden slips are placed under the track. Okay, first they lay down wooden slips. First they lay down wooden slips, then on the wooden slip they put the track. Why is this wooden slip needed? If the wheels of wheels of train, they roll on the track. Okay, they don't need the wooden slip. But why wooden slip is laid? It is because if wooden slip is not laid, then because of the weight of rail, this track might sink in the ground. Okay, however, by keeping the wooden slip, it increases surface area. Wooden slips increase surface area. Okay, and it decreases the pressure. Okay, that is reason. And another question number 3. Which one penetrates soil deeper, a lady's pencil heel or a flat sandal? Okay, next question. Studs are made on the sole of shoes worn by football players. Why? Okay, if this is the football player shoes, then in case of normal shoes, heels are made just like this, yes, but in case of football player shoes, this kind of studs are provided. Have you noticed it or not? The studs are provided, or goti are provided. Why? It decreases surface area and increases pressure, so that there is less chance of falling down while running. Okay, if you try to run with flat shoes, notice this, you cannot gain speed. If you try to run with flat shoes, you cannot gain enough speed. But if you run with shoes with stud, you can gain enough speed. That is one advantage. Okay, so I'll try to attempt these four questions. Tomorrow also we will take combined class. Tomorrow we will study liquid pressure, and liquid pressure is needed in both grade 8 and 10. So tomorrow also class will be combined for grade 8 and 10. Okay, this was for today. Thank you.